In the 1940s and 50s, chemical waste was buried beneath what would later become a quiet suburban neighborhood. The Love Canal site in Niagara Falls, New York, had begun as an abandoned canal excavation. Decades later, Hooker Chemical used the trench to dispose of more than 20,000 tons of toxic waste, sealing it in drums and covering it with clay. In 1953, the land was sold to the local school board for $1. An elementary school was built on top. Homes followed. By the 1970s, after heavy rains, chemical odors drifted through the neighborhood. Black sludge surfaced in yards. Oily residue seeped into basements. Families reported miscarriages, birth defects, seizures, and elevated cancer rates. Tests confirmed that toxic compounds had leached into the soil and groundwater, spreading beyond the original dump site. In 1978, a federal public health emergency was declared, and hundreds of families were evacuated. Love Canal became a national symbol of concealed industrial waste and led directly to the creation of the Superfund program. The broader lesson was stark. Burying a problem does not eliminate it. It only delays its return. This is worth knowing. Today, we're looking at places poisoned by industry and the consequences that linger. In the 1930s, a chemical factory on the coast of Minamata, Japan began discharging wastewater into Minamata Bay. The plant, operated by the Chiso Corporation, used mercury in the production of acetaldehyde. For decades, untreated industrial effluent flowed directly into the water. The mercury did not dissipate. It accumulated in fish and shellfish, staples of the local diet. By the 1950s, residents began noticing strange symptoms. Cats staggered through the streets, convulsing. Fishermen developed tremors, slurred speech, and loss of motor control. Children were born with severe neurological impairments. The condition came to be known as Minamata Disease. Investigations eventually confirmed mercury poisoning, but acknowledgement came slowly. The factory continued discharging waste even after the connection was suspected. It was not until 1968 that the government officially recognized the cause. Minamata became one of the most documented cases of industrial bioaccumulation in history. Its broader lesson was not just that pollution spreads, but that it concentrates quietly in living bodies. On the night of December 2, 1984, a pesticide plant in Bhopal, India released a cloud of toxic gas into the air. The facility, operated by Union Carbide, stored large quantities of methyl isocyanate, a highly reactive chemical used in pesticide production. Shortly after midnight, water entered a storage tank, triggering a runaway chemical reaction. Pressure built rapidly. Safety systems were either malfunctioning or turned off. A dense, invisible gas began drifting beyond the factory walls and into nearby neighborhoods. Residents woke coughing and choking. Eyes burned, lungs filled with fluid. People fled into the streets in darkness, many collapsing before they understood what was happening. Hospitals were overwhelmed within hours. By morning, thousands were dead. In the years that followed, estimates of the total death toll climbed into the tens of thousands, with hundreds of thousands more suffering long-term respiratory damage, blindness, neurological disorders, and birth defects. The Bhopal Disaster remains one of the deadliest industrial accidents in history. Its enduring lesson was not just about chemical danger, but about what happens when safety systems fail and when cost-cutting replaces accountability. The Citarum River runs through West Java, Indonesia, supplying water to farms, factories, and millions of residents along its banks. Over the past several decades, rapid industrialization transformed the river into a disposal channel. Hundreds of textile factories line its watershed, many discharging untreated wastewater directly into the current. The river also carries household sewage and an immense volume of plastic waste. In some stretches, the surface is no longer visible beneath layers of debris. Testing has revealed high concentrations of heavy metals, dyes, and chemical residues in the water and sediment. Fishermen report declining catches. Farmers irrigate crops with contaminated water. Residents wade into the river to collect recyclable plastic, often standing waist-deep in polluted sludge. Despite repeated cleanup initiatives and military-led waste removal efforts, the scale of contamination remains severe. The Citarum has frequently been described as one of the most polluted rivers in the world. Its broader lesson is not about a single accident, but about accumulation. Pollution does not always arrive in a single cloud or explosion. Sometimes it builds slowly, carried downstream, until an entire ecosystem is altered. Tar Creek flows through northeastern Oklahoma, cutting across what was once one of the most productive zinc and lead mining regions in the United States. Beginning in the early 1900s, intensive mining left behind vast piles of crushed rock known as chat. When the mines were abandoned, groundwater flooded the tunnels, leaching lead, zinc, and cadmium into nearby streams. Tar Creek turned an unnatural orange-red as acidic, metal-laden water seeped to the surface. Residents noticed the effects quickly. Children played in contaminated soil. Dust from chat piles blew through neighborhoods. Blood tests revealed elevated lead levels, especially among young children. Fish disappeared from the creek. Wells became unsafe to drink from. By the 1980s, the area was designated a Superfund site. Cleanup efforts stretched on for decades, but the damage was extensive. Entire towns, including Pitcher, Oklahoma, were gradually abandoned as health risks mounted and buyouts relocated remaining residents. Tar Creek stands as a reminder that industrial extraction does not end when production stops. Waste persists, often outlasting the communities built around it. This was worth knowing. Quiet facts, big consequences.